let me discuss the current in different situations like conductors, electrolyte, semiconductors, discharge tube and vacuum tube. In the case of conductors, electrons are responsible for conductance of electricity. In fact, when the electron in a conductor is moving in this direction, okay, the current is indicated in the opposite direction. Are you able to follow? Then, in the case of electrolyte, what is electrolyte? Electrolyte is the ionic conductor. It can be an acid or base or salt that can conduct electricity either in molten form or in solution form. So here you have got positive ions and negative ions. Let me consider sodium chloride. If it is a molten sodium chloride, it is like a liquid. If it is a dissolved sodium chloride solution, that is also in liquid form. So the positive ions, in this case sodium ions, Na plus, negative ions, Cl minus ions. So they will be moving here and there, and it is because of the ionic transportation the conductance is possible, the current is possible here. And in the case of semiconductors, that is, electrons are responsible for conductance as well holes. Holes means that is, it's called positive holes. So because of the, for example, you have got one atom with electron, another atom with electron, another atom with electron. Let me say one electron is jumping to the other place, okay, and from where it can jump to other place. So when the electrons are moving in this way, what about the holes? They will be moving in the reverse direction. Are you able to follow? And that is why the direction of here, the direction of electron is in this way, but the current is indicated in the opposite direction, I. Here the hole will be moving in this way, and therefore the current is along the same direction of the hole. So this is called positive hole. Positive hole means that is current will also be in the same direction, because this positive hole is moving in the opposite direction to that of electron. Are you able to follow? Let me say there are a few seats who are waiting for the, there are some patients, patient 1, patient 2, patient 3. Let me say this is P1, patient 2, patient 3. They are waiting for a discussion or counseling with a doctor in the clinic. So the patient 1 is going there, okay, and immediately, that is, the patient 2 will be moving here and patient 3 will be moving here. Now what happens? The empty seat will be moving in the opposite direction. Are you able to follow? Okay, this is called the positive hole. And what about this movement? This is electron and this is positive hole. And that is why the current is indicated in this case opposite to the electronic movement, and here it is along the direction of positive hole movement. Okay, this is the case with semiconductor. And first of all, you should know what semiconductor is. Semiconductor means, for instance, you have got a conductor. In a conductor you have a valency band and a conduction band is overlapped here. This is called the valency band and this is conduction band, and this is the energy in a conductor. Okay, so the electrons available in this valency band will be available in the conduction band also, and that is why it's a good conductor. Are you able to follow? Whereas in the case of insulator, let me talk about the non-conductor, insulator. Here there is a wide energy gap. The conduction band will be like this and the valency band will be like this. So this is a valency band and this is a conduction band. Now there is an energy gap, wide energy gap is there. And these electrons available here may not be jumping to the higher position. Okay, so they are not available for conductance. So they result insulator. So no conductance of electricity takes place. But in the case of semiconductor, which is in between these two, okay, here the energy gap is smaller, okay, so that by applying certain amount of heat, the electron will be jumping to the conduction band, because this forbidden energy gap delta is less. So in the case of intrinsic semiconductor, intrinsic means by its nature, when it is heated, so the electrons are excited to the higher energy level and thereby it starts conducting electricity. I will be explaining about the semiconductor in detail in the respective topic. Okay, right. Now let me come back. So in the case of semiconductor, as we already discussed, the electrons are responsible for conductance as well the holes, but their directions are opposite. And what about the discharge tube? In the discharge tube means under reduced pressure, there will be a back tube under reduced pressure of certain gas, atomic level. In the atomic level, you will be having positive ions and negative ions along with electrons. Okay, and it is because of the movement of these ions and electrons, the conductance is feasible. Thereby the current is feasible. And in the case of vacuum tube, where no gas is there, completely vacuum, so here you cannot talk about ions, where the electrons are responsible for conductance of electricity. So likewise, the current can be explained under different situations. Okay, so current, you can give a title like this: current in different situations. Take down current in different situations. Are you able to follow this? Okay.